Everyone, welcome back to my YouTube channel. Today we will discuss a system design called as RAG freshness. A policy document was updated this morning, but the RAG system is still answer using yesterday's policy. So how do we design indexing and cache invalidation so stale answers stop showing up? So imagine this. Legal team updates a policy at 9 a.m. At 11 a.m., your chatbot still gives the old policy answer. That is the trust problem. Today, we will design a beginner friendly RAG freshness architecture that solves this. So, what this video teaches, by the end of this video, you will understand why stale answers happen in RAG, what to update after a document change, how to invalidate cache safely, a simple HLD you can draw in Excel draw. So first we have to do problem framing in simple words. RAG has multiple layers. If one layer is old, the answer can become old. The important layers are document storage, chunking and embedding, vector index, retrieval cache, final answer cache. So our goal when document updates, new answers should become visible quickly. Okay. Freshness target. So updated content within 2 minutes. Requirements. So there are functional requirements. So detect document updates, uh, documents updates, reprocess only change documents, rebuild index entry for change content, invalidate stale caches, avoid serving old answer after switch. Similarly, there will be non-functional requirements, freshness under 2 minutes, high availability during updates, uh, works during burst updates, traceability of answer to document version. So we will do a quick estimation, which is called as back of the envelope estimation. So use simple numbers while like we will do 1 million documents in total, 10,000 document updates per day. So it comes around 30 updates per second and 2000 query QPS. What this means, update pipeline must handle burst, cache invalidation must be targeted, not global, versioning is required. Now we will design a high level design. Okay. So for that, I will insert that one. Okay. So I'll explain what it is. The source policy is there where all our documents are stored. So whenever there will be any change, event goes to a update event queue and then re-index worker uh, consume that event. Worker chunks and updated document into the vector index generation. This will be a new index where that's why it is called as n plus 1. Data is written to the new index generation. Alias switcher points production alias to the new generation. So when API user query was happening, right? So retriever service was just picking the document from the old vector index. So this switcher will switch between these two vector indexes. cache invalidation worker clear this cache invalidation worker will invalidate the cache, and it will it will bring fresh data to the answer cache. So it will be like this one, and we will pick it this one. So this is invalidate version, and this is not this one. This is also, yeah, this will also invalidate cache here. So we will put one arrow here also. This will be like that, and this is our monitoring layer. So never edit the active index in place. Build new generation first, then switch alias on, means first it will be generated and only it will be switched uh, with the old one. Why alias switch is needed? Alias switch means we change one pointer, not the whole system. Before switch, user read from the old stable index, no half updated index, no partial rollout confusion. So, short line for interview. Alias switch gives atomic cutover from the old index to the new index. You are not seeing two different databases. You are seeing two versions of the same index. So, first box vector index alias current. This is the live index used by user right now. And second one generation n plus 1. This is the newly built version created after document updates. Why do we keep both temporarily? We keep serving user from the current index without downtime. We build new index safely in parallel. When new index is ready, alias switch automatically to the new one. If something fails, rollback is easy because we have two versions available. One live read index plus one next build index connected by an atomic alias switch. Now, version model. So it is super important. Track three versions. So document version will be tracked, chunk version or chunk set version will be tracked, and index generation will be tracked. Every answer should store citation plus version. So whenever user is getting answer, right, so it should have citation from which document it got the answer plus the version of that document, so you can prove this why this answer was generated here. So cache invalidation made simple. Use version aware cache keys. So cache keys should be like that: tenant colon doc id colon index gen colon query hash, like that we have in the low level design. So it will be like we have to design invalidation worker also. So why this version cache keys matter? If index generation change, cache key also change. That means old cache entries become natural stale without waiting for long TTL expiry. This is safer than only deleting keys manually because key mismatch itself prevent stale reads. So a short line for the interview: version in key is a built-in state read uh, state read guard. When alias switches to the new index generation, um, old keys are automatically stale. TTL is still useful, but correctness should not only depend only on TTL. Why TTL only is risky? TTL controls when cache expires, not when truth changes. So if a policy changed now, TTL expires after 30 minutes. User can see wrong answer for the 30 minutes, right? So TTL is cost optimization, not correctness logic. So invalidate these caches, retrieval cache, answer cache, and embedding or chunk cache. So embedding cache also will be there. Race condition can be happen. Old job finishes late and overrides new data. Okay. So fix this, we need idempotency key. So doc ID plus version can be the idempotency key. Only allow writes if incoming version is latest. And we can add that letter Q for the failed events here. Alerts on freshness lag, if there is any lag for the freshness that we can add in the monitoring. And alerts on the stale answer rate. So there will be some metrics which we will track how stale are the answers. So if freshness lag goes above SLO, that is production incident. So invalidation worker flow we are saying, right? So consume the update in a event, find impacted cache keys, wait until new index generation is active, invalidate retrieval and answer key, and mark document as fresh. So there are some trade-offs also. So these are the trade-offs. TTL TTL only approach is easy, but still answer can survive longer. Event driven invalidation, pressure but more moving parts. Full reindex, simple reconsistency, high cost. So partial reindex, low cost but need strong version safety. So final design decisions are event driven update pipeline is there. So blue green index generation, because this one will be blue, this one will be green, and this one is blue, means when data is not updated it will be served from this one, and once the index is generated, after that the alias switcher will switch back to this new index, and we will get fresh answers. Atomic alias switch, this alias switch is very critical here. Version aware cache keys are very thing, because we need to uh, update these cache also. Invalidation after alias activation should happen, and observability on freshness lag is very. Fresh answers are not luck. Fresh answers are a version pipeline plus safe invalidation. If you want next, I can make a coding walkthrough plus Q worker plus Reddit, that is invalidation plus index alias switch. Thanks for watching, and please like, share and subscribe.